All right, my friends, today is the day. I'm a little bit nervous at how this process is going to go, and I'm a little bit unsure whether I can get it all done within one day, but the plan is today to, on my Voron 2.4 here, remove the Stealthburner toolhead that's back there and replace it with the Dragon Burner that we've been building here in this little mini-series for the last couple of episodes. So you haven't seen that toolhead yet, the Dragon Burner all built. This is it completed. I just finished building it yesterday, and I've got some B-roll footage I'll show you of this going together. It was fairly simple. It wasn't anything unusual, and we have built a Dragon Burner here on the channel before when I was building my V0 printer. So I'm not going to show the entire process here. I will link up in the corner right now of this video over to that V0 build series and the Dragon Burner episode specifically if you're interested in seeing how one of these things goes together. But it was very straightforward. The only difference is here where we have my filament sensor, this custom one that we designed in the previous episode on this series, mounted here on the top, and then we have our beacon probe down here, and so both of those needed to be wired into the toolhead PCB, and that turned out to be not very hard at all, other than on this toolhead PCB, all of these connectors are a different size. They're not the standard size. Even like the fan ones had to be replaced from the connectors that came on the fans. And so the majority of the process of putting this thing together was just crimping pins and putting connectors on all of the ends of all of the wires, which in a way was good because it allowed me to cut all the wires to length so that we end up with this nice clean look here where we don't really have any excess wire. Everything's just about the length that it needs to be, and so the end result looks nice and clean, and I'm happy with that. So you'll see here right at the moment we have the X carriage mount as well screwed here onto the back of the print head already. Obviously I'm going to have to take that off at some point later today to get this installed on the printer, but I again wanted to get all the cables the right length, including this one down here to the beacon probe. So I went ahead and put the whole thing together so that I could get the cable lengths all figured out and cut the wires to the lengths that they needed to be, and then we'll disassemble, like I said, and put this thing on the X carriage first and then mount the tool head hopefully later today. But before we get to that, I need to go ahead and take all of the side panels and the door off of this printer, and then I'm going to go ahead and remove the Stealthburner print head that's in there now. And because we're switching from the CAN bus setup that I have already on the printer to this new Nighthawk setup, which is like CAN bus but it runs over USB, it needs a different cable. So the umbilical cable and all of the cabling that runs up to it also needs to be removed, and the little panel in the back here where the umbilical runs through, and I'm going to actually remove this filament sensor as well because now we have one on our print head, so we don't need this one here anymore. So all of that's going to get removed, and where it connects down in the electronics compartment down below, that will get removed as well. Alright, so with the Stealthburner and the CNC tap removed here from the X carriage, I was going to flip this thing over and go ahead and remove the other end of the umbilical cable from the electronics compartment down below, but I don't want to lose these belts, and they're just kind of hanging loose at the moment. So I'm going to go ahead and take the X carriage mount off of the new Dragon Burner here and go ahead and mount that here on our rail and get the belts all fastened into here so that they don't get loosened any more than they already are when I flip this thing over to work on the electronics compartment. So I'm going to go ahead and do that first, kind of tidy this top part up, then we'll go underneath and remove the rest of the other end of the umbilical cable from the old system from the electronics compartment down below. So yeah, this first, then flip it over. Alright, so down here in the electronics bay, it's going to be a bit hard, I think, for the camera to see this just because of the angle. But the way this works is that the CAN bus board had this little breakout PCB here that is separate and mounted on our DIN rail here that I can just completely remove, I believe, once I unplug everything from it. It just took power and then a USB connection from our Raspberry Pi, and then it sent the signal up to this cable that went up through our umbilical to our tool head. And so the new Nighthawk system came with a similar type of a setup. It's a much smaller PCB, but it'll mount right here in the same spot that this one was. And so we can just remove this here and then reroute the power that's going into this into the new board. So it takes also 24 volt power, and it takes a USB connection from the Raspberry Pi. It came with its own cable, but I might just use this cable here because it's already routed through my my cable channels here. And yeah, so the new Nighthawk board PCB that came with the Nighthawk will go there in that same spot where this one was. And we'll plug it into power, we'll plug it into the Raspberry Pi, and then we will take its cable, its umbilical cable, which is different from this one, has a different connector and a different number of wires in it as well. And we'll remove this one completely, and then we'll hook the new one in and run it up the back. We're actually not going to run this one up the back of the printer. This one had been running out and up the back of the printer and then up near the top. We're going to run the new one up here through the Z cable chain that I still have in place, and then we're going to jump it from the back of the gantry over to the print head instead. So we'll build that umbilical in a bit, but for now I just need to get this removed and the new one put in place, and then the USB and power hooked up to that thing, and we should be good to go. Alright, so there's our umbilical plugged in. I've got to go ahead and this toolhead PCB mount came with some nice little slots here to put zip ties through. So I can go ahead and lock it into place. But I've measured it up to the front corner here of its range of motion, and so that should, with any luck, give us a good length. And then as soon as I finish tying this down, I'll move it to the back corner, which is as close to the place where it comes out over there that it's going to get, and we'll see how high the cable gets. Alright, so connector's back on the end of this cable. We do have quite a lot of slack down here, but I'm not going to worry about it too much. I don't really have a cable channel to run this into. It's coming down right here, and it just needs to plug in right there. And so I'm just going to leave the slack for now, get this plugged in. I might reopen this after we're sure that all of this works and is good, and then go back in and try to clean this up a bit. But for now, I'm just going to leave it like this. I'm actually not even going to button up the bottom here, because just in case there's a problem, I might need to get back down here again. So I'm just going to go ahead and set this back up, and everything is plugged in underneath. So we should be able to boot up our Raspberry Pi and see if it will connect to our USB devices, right? We should see two of them. We should see the toolhead PCB. We should also see the beacon probe, which is chained off of the toolhead PCB on its little USB extension port. And so I'm going to go get the Raspberry Pi booted up. We're going to look at how things are looking, make sure that we can see both of those devices, and then we'll figure out what to do about configuration of everything. I'm not sure if I want to try to work with what I already have, which already has CAN bus installed and some other things that I'm not going to need anymore, or whether I want to create a brand new Raspberry Pi image on a separate SD card and just start from scratch and reconfigure everything from scratch. I'm still kind of debating what to do about that. But for now, let's just kind of smoke test this. Hopefully no smoke comes out, right? But we'll test this thing out and make sure that we can at least see all the devices and that everything looks okay. And then I'll decide what to do about the kind of the final configuration of the Pi and Clipper once I think about it a little bit more. Alright, so the printer started up, it's got power. The Raspberry Pi did boot. Clipper didn't start correctly, and that was expected, right? Because we've removed some CAN bus devices that it's looking for in the Clipper configuration. So the message on my Clipper screen there is saying that it's missing one of the MCUs that it's looking for when it starts up, and that's fine. I've SSH'd over into the device itself, and if I do an LS USB, which I've already done, but I'll do here for you as well, we can see this OpenMoko RP2040 here. That should be the toolhead PCB for our Nighthawk, and then I can also see the beacon, right? It's a beacon Rev H. So both of those devices are on our USB bus, which is great. That means that my little extension cable that I built for going from the toolhead PCB over to the beacon is working correctly. I can also do like an LS dev serial by ID here as well, and I can see the beacon and I can see the RP2040. So both of those devices should be what we need in our configuration. Now, what I'm going to do, I have decided, I've backed up all of my Clipper config, copying it off of the Raspberry Pi onto my computer here, And I'm going to go ahead and power this thing down. I'm going to take the micro SD card out of the Raspberry Pi, and I do have a spare one here that should be large enough. I think it's 32 gig or maybe 16, but either way, it should be fine. I'm going to go ahead and flash a brand new Raspberry Pi image. Then I'm going to install the Klipper install and update helper on there and use its menu system to go ahead and install a clean copy of Klipper and the other things that we need. I've done that before here on the channel on the V0 build series, so I'm not going to show that here in this video. It's kind of a long process. I'll do that off camera here on my own. And that way, if there's ever any problems, I still have the SD card from the original version that had the CAN bus installed and everything as well, and I can switch back to that if I need to. Doesn't look like I'm going to need to because, like I said, this is looking promising as far as seeing our devices, and everything looks good. So I'm going to go away probably for a few hours and do all of that install and get the Raspberry Pi reconfigured, and then we'll come back and I'll show you the configuration that I've ended up with, and we'll do some testing to make sure that everything on our new printhead is working correctly. Hey, we're back. So I've got all the software installed and I've done some configuration. I think we're ready to go ahead and test this thing out. Before I button it back up and put the sides back on and, you know, the acrylic enclosure and everything, I wanted to just show you a couple other things that I did. So there's a new little back panel up here that just has the filament coming through. This, you know, before I had my CAN bus cable coming through as well. So this is just here. The other end of it right now is just here. I haven't really managed where that's going to go outside of the case yet, but this is on this nice little print-in-place ball joint. So as with everything else that I've mentioned in this video, and like I usually do, I'll put links in the description down below to the different parts that I've printed out to add on to this thing. But this is pretty cool. This thing moves around very easily, and I've put a little bit of my PTFE grease as well into that print-in-place ball joint. And so this should be really good as the print head moves around to feed our filament in. I think everything else is working, so I'm going to go ahead and button this back up. Like I said, push it back in the corner where it goes, and then we'll connect to it over its web UI and do some testing with the beacon probe. Maybe that's what you're here for, because you saw beacon on the thumbnail of the video or in the description. Yeah, we'll give that a try in just a minute, do some bed meshing and see what that looks like.
3 days later.
Okay, my friends, we need to pause this process here and talk for just a second, because I've spent the last couple of days not having a fun time with this printer. Everything was working. In the last segment that you just watched, I had put everything together and I did some testing that night and it was all working great. And then the next morning I went to record the segment to show you guys kind of how the beacon probe works. We were going to do some bed meshing with it and all that kind of stuff. And I started having intermittent problems, both with the Nighthawk toolhead PCB and with the beacon. Both of them, Klipper kept reporting that they were disconnecting, and then it had to restart, and it was just very strange. When they worked, I actually was able to print a couple of things with the printer, and it worked great. But then, like I said, intermittent problems. And so I figured it was a cable problem of some kind. I spent a long time trying to troubleshoot this umbilical cable here to the toolhead PCB, and it seems like it's okay. But then what I figured out, finally, after a lot of trial and error, is this little cable that I made that jumps from the output. There's a USB like chain connection on the back of the Nighthawk toolhead board, and it was going down to the beacon. So I had the beacon chained off of the Nighthawk, and it seems like that's the problem. So I've double-checked this cable. I've actually remade it twice, and every single time I think the cable is fine, and when I plug it in, it works for a while, and then I start to have intermittent problems with it. So I'm not sure if it's my problem, if I'm making bad cables, or if the USB chaining functionality on the Nighthawk is not that good. It could be one or the other, but what I've decided to do for now is, and I hate to have to do this because I really liked the solution of chaining the beacon straight off of the Nighthawk, but what I've decided to do is run a separate cable. So right now I have this other USB cable, and it's just run to the USB port on the front of the printer, which connects into the Pi, and this is going to the beacon on the back underside of the tool head here. And so I have two separate USB cables running, and I've disconnected this little chained cable here from one to the other, and now everything works. So I can, like home everything, as long as I'm careful to hold these cables out of the way, because, I don't have them run in a nice way yet. But the sensorless homing will now pull that y-axis back, the x-axis over. It'll come out to the middle of the bed, and it uses beacon then to probe the Z. And that seems to work fine. I can quad gantry level as well, which again is using beacon. And this is stuff that I was having trouble with, like about probably more than 50%, maybe 75% of the time. QGL would just fail at some point around the bed. It would say that it wasn't getting a reading from beacon anymore, and then the entire Nighthawk toolhead PCV would disconnect from Clipper. And so I've done this a few times now with this configuration as it is now, and it's working okay. So as much as it pains me to have to do this, I'm going to have to run this second USB cable through the umbilical as well. I'm going to have to get kind of a wider something to go on the outside of these two cables to hold them together. So that's going to take me a couple more days to kind of figure all this out and get it cleaned up and working nicely. But yeah, I just wanted to jump in here and say, before we move on and I show you all the cool stuff that the toolhead can do, which it will be the next segment, just realize that there was like a period of, it's going to be like almost a week in here where I was troubleshooting this, and the problem turned out to be the chained USB connection off of the Nighthawk into the beacon. So again, not sure if it's a problem with the Nighthawk, not sure if it's my problem with the cable that I was making or something else, but that's what I found, and so this is going to be my solution for it, is to run two separate USB cables. I'll get all this cleaned up, then we'll move on and I'll show you all the cool stuff that the toolhead can do. And so that'll be coming up next, but for me, I got a couple days of cleanup work to do first. See you in a bit. Alright, I've got the USB cable umbilical situation all sorted out, I think. And we've got a live camera pointed on the printer. Let me go ahead and turn the lights on over there so you guys can see this on the screen. So the right half of the screen is my mainsail UI, and the left half is the live camera on the printer. And while I just go ahead and home everything, I will mention that when I reinstalled Clipper here on the Raspberry Pi on a brand new micro SD card, I decided to try out ClipPane, which is a open source Clipper configuration utility, I guess. It's a set of configuration files. It's really easy to set up, and I don't really have time in this video to talk about it, but if you're interested in that, leave a comment down below. I could make a whole separate episode on ClipPane. I will put a link to it in the description of this video, so if you're interested, you can go look at that. And yeah, we should be good to go. So we've got this all homed. Once you've installed a beacon probe, as I've done here, the first thing you're going to have to do is calibrate it. And I've already done that with mine, but there are a couple different ways to calibrate beacon. One is that you can just type beacon calibrate here in your console, and when you do that, you get, if you've ever done any sort of Z-probe configuration or manual calibration with Clipper before, you get this UI that looks fairly similar to that. So this allows you to nudge the nozzle down until you get it just the right height above the bed, and what they recommend is that you put a piece of paper in between the bed and the nozzle, and you manually nudge it down until you get just the right amount of, just a tiny bit of resistance trying to move that piece of paper. I'm not going to do it that way though, because I don't find that to be super accurate, right? It's a bit subjective as far as moving that paper around and getting it just like you want it. So I'm going to abort out of here. What I did instead is I used a auto calibration feature that is with some of the newer versions of the Beacon firmware. So there is a Beacon auto calibrate command now, and what this does is it uses Beacon contact, which actually moves the tool head down until the nozzle just barely contacts the surface of your print bed. So it'll hit the build plate. The camera here doesn't show a good enough angle probably to see that actually touch. No, not really. But you can see here in the console that it takes 3 different samples, so it's moving down and touching the bed 3 times, and assuming that those are very close to each other in height, which in this case they were, then it goes and moves around a little bit and calibrates the Beacon magnetic probe there. So now with that command that just showed up there, and I did not speed that video footage up at all, so that's real time how long it takes. We have a calibrated beacon, and I could do save config here to save this in my printer config file so that it gets loaded every time I restart the printer. Since I've already done that, I'm not going to do that again today or on this video here, but now Beacon is all calibrated, and so we could do things like quad gantry level, and when we do that, it uses the Beacon for the Z height. So this is not currently set in my configuration to use beacon contact. It's using its proximity measurement, which means it moves down to about 2 millimeters away from the surface of the bed, and it triggers the eddy probe, and then it calculates the height from that. So I'll let this go around a couple of times until it gets calibrated. I'll go ahead and speed this footage up because I'm sure you've seen a QGL procedure before. Alright, so our gantry's level. The next thing we could look at is I could do a bed mesh here for you guys. So typically, in my setup that I've got here right now, I do an adaptive bed mesh. So before I print, I do a bed mesh on just the part of the print surface that's going to be printed on. But if we do a bed mesh calibrate here without any of that auto calibration stuff, it should just mesh the entire surface. So this I'm not speeding up. So this is real time. So you can see how quickly this beacon probe does its job. And I believe right now it's doing a 9x9 grid for the mesh. So it goes to the back corner and then it snakes its way back from the back to the front. So it's actually doing 2 passes over the bed here. And there it's finished. And so now we can go over here and look at our height map, and we can see the mesh that it calculated. Yeah, it was a 9x9, and just looking at the image here that it got, and knowing how my printer's bed is, I believe that this is probably very accurate. I know I have a high spot in the front middle and an even higher one in the back middle. So that looks pretty good. The range from the highest to the lowest point is 0.111 millimeter, and that seems probably about right as well. So again, I could modify params on the beacon setup and do an even finer mesh, more than 9x9 points. The amount of time taken to do that would be just about the same. It doesn't have to move the print head much slower than that to do a finer mesh than what I've got here. But I think a 9x9, especially if I'm doing adaptive meshing most of the time anyway, is going to be fine. So again, we could save config here, and we could save that bed mesh in our printer config, and it could get reloaded every time that we load our printer. But since I'm doing an adaptive bed mesh before every print, I'm not going to worry about that here either. So that's kind of your basic setup for beacon. I want to show you guys the first layer. So what I'm going to do is I'm going to go ahead and queue up a 1 layer high print that's a big square that just covers most of the bed. I'll print that in a color of filament that should stand out against the surface of that build plate pretty well, so that we can see if there's any gaps or problems as it prints. So I'll show you some time-lapse footage of that thing printing, and then I'll pull that off the bed. We'll take a look at that as kind of the final little piece for this episode. Alright, so that first layer finished, and I just pulled the whole build plate off the printer so that we could bring it over here. This has already kind of come loose from the build plate, but this serves as a nice dark background. I tried to pick a dark colored build plate and then a lighter colored filament so that we could see any inconsistencies. First thing I noticed is I left a greasy fingerprint on the build plate over here on the side, so we had a little adhesion issue there. That's not because of the new tool head or the extruder or anything like that. It's just my fingerprint was on the build plate. And then the other thing I noticed is up here in the top back corners, both of them, it's a little bit those are the spots where I know my build plate is a little bit lower. It's a little bit under extruded. So probably I could use with tuning this filament. This was just a spare roll of PLA that I had laying around. It's probably been sitting here in the studio for a couple of years. So it's not in the best shape as far as humidity absorption and things like that, but it did turn out pretty good. So I'm overall quite happy with like the just the overall surface, top and the back side as well. Now that I've pulled it off the build plate, this looks really, really good. And I suppose I could grab my calipers here and we could check to see the thickness of it. So I'm going to zero those out and just pick a spot along here and measure. I'm getting 0.19, 0.2, 0.21. Yeah. So that's looking really accurate as well as far as the height of our first layer. So yeah, I think overall I'm super happy with how this is turning out so far. Now going forward, just printing a first layer was fun for testing how the beacon probe is working and making sure that the bed mesh is working well to give us a nice consistent first layer. And that looks good. I do have some additional testing I can do with the tool head. I haven't tested, this extruder and this hot end very much. I haven't tested my custom filament sensor that I built. All of those things I will do over the next couple of days and just make sure that those are all working well and looking good. I probably won't make another video in this series on that unless I run into anything unexpected or unusual or interesting that I think would be worth showing to you guys. Otherwise, it's going to be just the basic, setting up a new printer type stuff where you're testing things out and figuring out what your max flow rates and speeds and things like that are. So I will do all of that stuff. Like I said, if I find anything interesting, I will report back here in a future video. If you guys have any questions or want me to test anything specifically with what you've seen so far that I've put onto this new tool head, let me know about those things down in the comments as well. I always try to read all the comments and respond to as many as I possibly can. And if it makes sense to respond as a comment, that's cool. Or if it makes sense to do it in a future video, I'll do it that way as well. So I don't know for sure if there will be another video in this little mini series playlist on the new Dragonburner tool head upgrade. It'll depend on what I find as I finish testing this thing out and any questions that you guys have. So this might be the end of the series. If it is, it was a fun process, although it was a bit convoluted in the middle there where I had to worry about all the issues with the USB connectivity. Now that it's working, I'm super happy with how it looks as far as how it's printing, and I'm looking forward to using it now that it's back. It's been out of service for about a week and a half while I was working through all those issues. So having it back in service will be great for getting back to actually printing some useful projects and not just first layer prints. And that'll be exciting. I'm looking forward to using it for real stuff again. And so I think that's gonna do it for this episode, maybe for the series as well. I hope you've enjoyed it. Like I said, if you have questions, leave them down below. I'll do my best to answer as many as I possibly can. And I hope you guys have a great day, and I'll see you next time.